Stereoisomers are high yield in the chemistry and physics section, and they show up in orgo passages, experimental setups, and discrete questions. The test loves to ask whether molecules are identical, enantiomers, or diastereomers, and if you know the rules, you'll avoid falling for traps. Let's break stereoisomers down step by step. What are stereoisomers? Stereoisomers have the same molecular formula and the same connectivity, but the atoms are arranged differently in 3D space. That subtle change is enough to completely alter chemical behavior on the MCAT. Types of stereoisomers. There are three main categories. Enantiomers. These are non-superimposable mirror images. Every chiral center flips. Diastereomers. Same connectivity, but not mirror images. Some chiral centers flip, others don't. They also have different physical properties, unlike enantiomers. Cis-trans isomers. These appear in double bonds or rings. Cis means similar groups are on the same side. Trans means they're across from each other. Chirality and chiral centers. A molecule is chiral if it has a non-superimposable mirror image. This usually means there's at least one asymmetric carbon, a tetrahedral carbon with 4 different substituents. Each chiral center doubles the possible stereoisomers, which is why the MCAT loves to test how many stereoisomers are possible than questions. Enantiomers and optical activity. Enantiomers are mirror images. They share identical physical properties like boiling point, solubility, and density. The one difference, they rotate plane polarized light in opposite directions. One is dextrorotatory plus, the other levorotatory minus. The MCAT expects you to know this distinction cold. Racemic mixtures. A racemic mixture is 50-50 enantiomers. Their rotations cancel, so the mixture shows no net optical activity. The MCAT often sets up experiments where the presence or absence of optical activity reveals whether the mixture is racemic or enriched in one enantiomer. Specific rotation. Specific rotation quantifies how much a chiral compound rotates polarized light. The formula is observed rotation divided by concentration times path length. For the exam, you don't need to calculate, but you should recognize what a positive or negative value means in terms of direction. Optical purity. Optical purity tells you how enriched a sample is in one enantiomer. It's calculated by comparing the observed rotation to the rotation of the pure enantiomer. High optical purity means the sample is mostly one enantiomer, not racemic. Stereoisomers show up again and again because they connect organic chemistry to experimental reasoning. If you can identify enantiomers, diastereomers, and cis-trans relationships, and apply concepts like chirality, racemic mixtures, and optical activity, you'll turn a tough orgo passage into easy points. With that said, here are just a few of our student success stories. Students who improved their scores and even got into medical school. If you're preparing for the MCAT, click the link below to get started with your own preparation. We specialize in helping students reach a 515+ score guarantee, and we'd love to help you too. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.